Assalamu alaikum. I am Muhammad Ali Hassan, Senior Lecturer, Department of Mathematics, Milestone College. I hope that student you are well. I am also well. Today I will discuss about differentiation chapter 9C. So look at the board. Student, derivative of product of two function. Now prove that ddx of uv, u ddx of v plus v ddx of u, where u is a function of x and v is a function of x. It's very important formula. Now proof, let f of x equals to let f of x equals to u v, or u is a function of x and v is a function of x. Now find the value of f of x plus h. Putting the value of x equals to x plus h. Now we can write u into x plus h and v x plus h. So student, here let f of x equals to ux into vx, and here find f of x plus h. We have value of f of x plus h equals to ux plus h and vx plus h. By the definition of first principle, we get ddx of f of x, equals to limit h tends to 0, f of x plus h minus f of x by h. Attention please student, here we know that by the definition of first principle, ddx of f of x equals to limit h tends to 0, f of x plus h minus f of x by h. Now putting the value of f of x, so we can write ddx of f of x is uv, so limit h tends to 0, and here putting the value of f of x, u x plus h into v x plus h minus ux into vx by h. Putting the value of f of x plus h equals to u of x plus h into v of x plus h minus ux into vx v of x by h. So student, here now limit h tends to 0, here ux plus h into vx plus h minus ux plus h vx and plus ux plus h into vx. Here adding ux plus h and subtract ux plus h into vx, and same as ux into vx by h. Student, attention please, here adding ux plus h into v of x plus h and subtract ux plus h into v of x. Now we can write here separating limit h tends to 0, ux plus h vx plus h minus ux plus h vx by h. Student, attention please, here separating all expression and plus u of x plus h vx minus u of x and v of x by h. So student, here limit h tends to 0, ux plus h and v of x plus h minus u x plus h vx by h. And now plus limit h tends to 0 ux plus h vx minus ux into v of x by h. So student, attention please, here limit h tends to 0. Now taking common ux plus h, taking common ux plus h, then we can write ux plus h, then we have v of x plus h minus vx by h, and then limit h tends to 0. Similarly, taking common vx from numerator, so here taking common vx from numerator, then we get v of x u of x plus h minus u of x by h. I say again student, here taking common u of x plus h from numerator, then we get v of x plus h minus v of x by h. Similarly, limit h tends to 0, taking common v of x from numerator, and then we get u of x plus h minus u of x by h. So student, here limit h tends to 0 u of x plus h, and limit h tends to 0 v of x plus h minus v of x by h, and then limit v of x, limit h tends to 0 u x plus h minus u of x by h. Then student, here putting the value of h tends to 0, so we can write u of x, and by the definition of first principle, then value of v of x plus h minus v of x by h, by the definition of first principle, then we can write v of x ddx of ddx of vx. I say again student, here limit h tends to 0 v of x plus h minus v of x by h, by the definition of first principle, this is ddx of vx, and plus v of x. Similarly, by the definition of first principle, then we can write ddx of u of x. So student, we can write u ddx of v plus v ddx of u. So we have ddx of uv equals to ddx u ddx of v plus v ddx of u. So student, attention please, product of derivative of product of two function means ddx of uv u ddx of v plus v ddx of u. So it is very important formula for your exam. Now student, memorize it, ddx of uv u ddx of v plus v ddx of u, where u is a function of x and v is a function of x. So student, I say again, memorize it, ddx of uv u ddx of v plus v ddx of u. Similarly, we can prove that ddx of u by v, derivative of division of two function, then we can prove that ddx of u by v, u is a function of x, v is a function of x, then we have v square v ddx of u minus u ddx of v. So Student, attention please here. Derivative of division of two function means dtx of uv. U by v, u is a function of x, v is a function of x. So ddx of u by v equals to v squared. Now v ddx of u minus u ddx of v. So student, memorize it. Derivative of division of two function means ddx of u by v. Similarly, division v square v ddx of u minus u ddx of v. It is very important question. Derivative of product of two function. For example, student, ddx of derivative of ddx of e to the power x sin x, e to the power x sin x. So student, here derivative of product of two function. Product of two function, here u is e to the power x and v is sin x. Now using this formula, ddx of uv equals to u ddx of v plus v ddx of u. Now let here e to the power x is u and v is sin x. So student, using formula u means ddx e to the power x and v means sin x. So u ddx of v and plus v ddx of u. Here v is sin x and u is e to the power x. So student, it is using formula u ddx of v, u ddx of v, then plus v ddx of u. So student, here e to the power x. Now we know that ddx of sin x, ddx of sin x is cos x and sin x e to the power ddx of e to the power x. Using formula, we know that ddx of e to the power x equals to e to the power x. I say again student, ddx of uv e to the power x into sin x. This is product of two function. Now using this formula, here u is e to the power x, v is sin x. So u ddx of v plus v ddx of u. So e to the power x. Now using formula, we know that ddx of sin x equals to cos x and sin x, then ddx of e to the power x means e to the power x. So taking common e to the power x, so we get cos x plus sin x. This is answer. Another example, student, here ddx of x square into e to the power x square e to the power x. Now student, here product of two function. So using this formula, here u is x square and v is e to the power x. Now student, here u ddx of v plus v ddx of u. U means x square. This is using formula. So x square, and we know that ddx of e to the power x, using formula we know that ddx of e to the power x means e to the power x and x square. So ddx of x square is 2x to the power 2 minus 1. So x square e to the power x plus 2x e to the power x. This is answer. I hope that student, you are clear. Question number 5. ddx of x square log a base x plus 7 e to the power x cos x. Now ddx of x square log a base x and plus 7 is a constant, so take it to the first position. d dx of e to the power x cos x, separating all expression. Now derivative of x square log a base x plus 7 e to the power x cos x. So student, d dx of x square log a base x, 7 constant, so take it to the first position, and d dx of e to the power x cos x. So student, using this formula, here product of two function, x square is u and log a base x is v. So u d dx of v, v means log a base x, and plus then v d dx of u means x square. So I say again student, attention please here, using formula d dx of uv, u d dx of v plus v d dx of u. Similarly, second condition here 7, it is using formula u d dx of v, product of two function. So u is e to the power x and v is cos x. Now using formula u d dx of v, v means cos x, plus cos x d dx of u, u means e to the power x. I hope that student you are clear using formula product of two function. So next line, x square, we know that d dx of log a base x, you have learned student formula d dx of log a base x 1 by x log a base e. So using this formula 1 by x log a base e and log a base x, x square, d dx of x square 2x to the power 2 minus 1, and then 7 into e to the power x, and cos x, we know that student d dx of cos x means sin x. Using formula d dx of cos x, you have learned student d dx of cos x equals to minus sin x. Then cos x and d dx of e to the power x means e to the power x. You have learned student formula d dx of e to the power x equals to e to the power x. So here x and x cancel. Now we have x log a base e plus 2x log a base x. 2x take it to the first position, and then plus minus will be minus 7 e to the power x sin x and plus 7 e to the power x cos x. Derivative of division of two functions, d dx of u by v, v d dx of u minus u d dx of v by v square. So using this formula, for example, here question number 10, d dx of root over x plus 1 by root over x minus 1. Here u is here root x plus 1 is u and root x minus 1 is v. So division of two functions. Now using this formula, student attention please, here root over, here v square, v means root over x minus 1 whole square means v square. Now here v dx of v and d dx of u, u means root x plus 1, and then minus v d dx of u. So u d dx of v, so root x plus 1 d dx of u, u means d dx of v, v means root x minus 1. I say again student, here u by v, v square, v d dx of u minus u d dx of v. Here u is root x plus 1 and v is root x minus 1. Memorize it student, d dx of u by v u ddx v ddx of u minus u ddx of v by v square. So using this formula, v ddx of u minus u ddx of v, then v square. Next line, student, here root x minus 1 whole square, here root x minus 1 and ddx of root x. We know that, student, we know that ddx of root x equals to 1 by 2 root x. This is formula. Now using this formula, 1 by 2 root over x and ddx of 1 constant, ddx of constant is always 0. So ddx of root x is 1 by 2 root x and 1 is 0. Then we have here ddx of root x means 1 by 2 root over x and ddx of 1 is 0. Student, attention please. Here root x minus 1, then ddx of root x is 1 by 2 root x and ddx of 1 is 0. We know that ddx of constant always 0. 1 is constant, so 1 is 0. And root x plus 1. Now root x means 1 by 2 root x and ddx of 1 constant is 0. Next line, student, here root x minus 1, 1 by 2 root over x and minus root x plus 1, 1 by 2 root over x by root x minus 1 whole square. Now taking common 1 by 2 root over x, then we get root x minus 1 and minus root x, minus plus will be minus by root x minus 1 whole square. Then here 1 root x cancel. So 1 by 2 root over x minus 1 means minus 2 by root x minus 1 whole square. 2 cancel. Then we get minus 1 by root over x minus 1 whole square. So result will be minus 1 by root over x into root over x minus 1 whole square. I hope that, student, you are clear. Student, question number 17. It is very important question for your exam. So look at the board. Here ddx of x sin x by 1 plus cos x, division of two function. So using formula, student, u by v. Here u is x sin x and v is 1 plus cos x. So using formula, division of two function, here v square, v means 1 plus cos x whole square. Now here v ddx of u means x sin x and minus u ddx of v means 1 plus cos x. So attention please, student, using formula division of two function, here v square, v ddx of u and u ddx of v means 1 plus cos x. So student, next line, here 1 plus cos x whole square, then 1 plus cos x. Student, here again using formula, here product of two function uv, product of two function. We know that ddx of uv, u ddx of v plus v ddx of u. So student, here using formula, u ddx of v means sin x and plus v ddx of u, using formula u ddx of v ddx of u, and then minus x sin x. We know that ddx of 1 1 means constant, so ddx of 1 is 0, plus cos x means minus sin x, so plus minus will be minus sin x. So attention, please student, here ddx of 1 is 0 and ddx of cos x, you have learned student this formula minus sin x. ddx of cos x means minus sin x, so using this formula. Again 1 plus cos x, here x, ddx of sin x is cos x and sin x, student, here ddx of x, formula, using formula ddx of x is 1 and then minus minus will be plus x sin square x and denominator is 1 plus cos x whole square. Now student, here 1 plus cos x whole square, then multiplication 1 x cos x plus sin x, and again cos x into x, cos x into cos x means cos square x, and cos x into sin x means sin x into cos x. Then we have x sin square x. Student, attention please, here product of two function, 1 into cos x means x cos x, 1 into sin x means sin x, and x cos x into x cos square x, sin x cos x, and this one x sin square x. Now we have 1 plus cos x whole square equals to this term and this term, so we can write x sin square x plus x cos square x. Now student, here x cos square x and x sin square x, then plus x cos x, and sin x plus sin x cos x. Then next line, here student, 1 plus cos x whole square, and here taking common x from first two terms, so we can write sin square x plus cos square x. Now here x cos x, and taking common sin x from last two terms, taking common sin x from last two terms. So student, we can write 1 plus cos x, 1 plus cos x. I say again student, here taking common x from first two terms and third term is same, and taking common sin x from last two terms. So student, next line, now we have here x into this, using formula we know that sin square x plus cos square x is 1. Now x cos x and sin x into 1 plus cos x by 1 plus cos x whole square. Then student, taking common x from first two terms, so taking common x from first two terms, we get 1 plus cos x and sin x into 1 plus cos x by 1 plus cos x whole square. Again student, taking common 1 plus cos x from numerator. Now we have student, here 1 plus cos x, 1 plus cos x means whole square. Now taking common 1 plus cos x from numerator, so we can write 1 plus cos x, and then we get x plus sin x. I say again student, here taking common 1 plus cos x from numerator, then we get x plus sin x. 1 plus sin x and 1 plus cos x and 1 plus cos x are cancelled. Then we get x plus sin x by 1 plus cos x. X plus sin x by 1 plus cos x. I hope that student you are clear. So student, memorize it. Product of two function d dx of uv, u d dx of v plus v d dx of u, and division of two function d dx of u by v equals to d dx v d dx of u minus u d dx of v by v square. Here u and v are, u is a function of x and v is a function of x. So it is very important for your examination. So student, see you again next class. Allah Hafiz.